Hello, here we present an alternate solution to problem 6 of EGMO 2020. The problem is to find all integers m for which the sequence whose first three terms are 1, 1 and 4 and the subsequent terms follow the recurrence relation given by this contains only perfect squares. We shall show that the sequence contains only perfect squares if and only if m equals 2 or m equals 10. So there are two parts, the if part and the only if part, and we shall begin with the only if part. We start by looking at the first few terms of the sequence. From the recurrence relation, it follows that a4 is 5m minus 1, a5 is 5m squared plus 3m minus 1, and a6 is 5m cubed plus 8m squared minus 2m minus 4. The key idea is to look at a4 times a6. In fact, we will consider 4 times a4 times a6, which is this quartic expression. We shall now compare this quartic expression with the squares of quadratic polynomials of m. We see that 10m squared plus 7m minus 7 whole square is close to the quartic expression but a bit less. So it is less than 4 times a4 times a6. And on the other hand, 10m squared plus 7m minus 5 whole square is bigger than 4 times a4 times a6. Given that a4 times a6 is a square, it follows that 4a4 a6 should equal 10m squared plus 7m minus 6 whole square, and so therefore this square should equal to the quartic expression we had before. Equating these two, we get a quadratic equation in m, which is m squared minus 12m plus 20 equals 0. Solving this, we get m equals 2 or 10. This completes the only if part. The solution to the if part is the same as the one in the other solution, but we present it here again for the sake of completeness. We write m equals t squared plus 1 with t equals 1 or t equals 3 for m equals 2 or 10. Then we consider a sequence which is essentially square root of an defined by b1 equals b2 equals 1, b3 equals 2, and bn equals t times bn minus 1 plus bn minus 2 for higher values of n. Then it is easy to see that an equals bn squared for n equals 1, 2, 3 and 4. And for higher values of n, we get from the recurrence relation bn squared plus bn minus 3 whole square will equal m times bn minus 1 whole square plus bn minus 2 square. So by induction, it will therefore follow that an equals bn squared for all n, and hence the if part follows. This completes the solution.